So in the last class, we were talking about files. And I think because you are in that class, you can remember what we said about files. And we said that files are composed of various types. And still, we said that these types are different in terms of size. And that's why we find that most of the files are classified into bytes. And each byte has its own presentations. So what we need to look at is the structuring of these files. And how should we structure the file so that we can be able to have different types that we always have. So if I can remember what we said, if I can use...
You are currently the only person in this conference.
If I can use the presentation with the PowerPoint, I remember we saying that one of the file that we have, one of the type file that we have what you call a document file. And automatically, this is always presented as .doc, meaning if you present a file as .doc, so we are saying this is a document file which has a defined size. So the factors
Can you hear me
include the factors. Okay, I can hear now. I can hear you now. Okay, so I hope you are clear.
Yeah, you're clear, very clear.
Oh, okay, so that's why I'm saying, last we were discussing about types, and we're saying that we have different types, and one of them was a document type, where we said we always use a .doc, meaning that a dot is an extension, and there are some factors that we need to look at. One of them is the size that we always have within files. And when you're talking about size, mostly we talk about size in terms of bytes. Size in terms of bytes. So that's why I remember saying, if you try to change a file, maybe we save this file in a document. If you save this file in a document location, so automatically we always have a document maybe file called h.doc. So if I try to create another one, maybe I try to create in the same location and I call it h.pdf. So it means this is not affecting this. It is not affecting this because now those are different types that are presented on that. And that's why we say that we need to have different properties for each and every file. And I remember if I can use a given example here, where maybe I use my desktop and I use this folder that I have here, or I use this file that I have here, or this. So if I right click this file and then I go to properties, so automatically, if you go to properties, there are some properties that you can see. One of them is the file type. The next one is the location. The next one is the size. The next one is the date modified. And maybe we have the file name. We can have the file name. Either that name is called maybe x.file. If you go to the directory, because we said we can still use folders as directories. If I go to a certain directory, I right click. So automatically, we will still have type. This is a file folder, location, size, the date that it was created. So all these are presentation of an attribute. And if you can see maybe the difference between the document file and a folder, you find that this is now presented as a Word document. If you use a PDF as a presentation, you find that now this is presented with a different, so open with Microsoft Edge, meaning if I want to change that maybe to PDF, I can change that. So automatically this changes to PDF. This is a folder and this is a Word. So that is what we are saying. We have different presentation of these files in different types. And the only thing that can do this is what you call the file system. The file system is the one that allows us to do this. That's why today I want us to start with directories. And for you to understand about directory, you must always be able to understand that directories are containers. And these containers are the folders that we create within our systems. So that's why if you look at the first thing that we have talked about, this folder that I have here now becomes a directory. This becomes a directory because previously we were calling directories. We were having directories in MS-DOS, but nowadays folders are the ones that we are calling them directories nowadays. And if you look at now the difference between files and directories, we always say that a file is a container or it's a collection of file, while a file is a collection of related information. So that's why we are saying these directories are used to organize files. So it organizes files and folders into a hierarchical manner. So when I say directories, current directories that we have are folders, I'm not wrong. Because now we are organizing them in a manner that the users will be able to understand them. That's why we have different types of directories. And one type of the directory that we have, we can have one level. We will explain that. One level directory. We have the two-level directory. Two-level directory. Then we have the acyclic level directory or acyclic graph directory. And then we have another one that we call a tree level directory. But if you look at most of the directory that we use these three directories. And the current systems that are now used today, we always use a cyclic level directory because of sharing files. And that's why, if you look at now the interpretation of the first directory that we are calling the single level directory or one level directory, is where we only have one entry. And this entry is where we only have various folders. Let me call them folders, or we have directory. And that's why we are saying the single level directory, simplest directory structure, in all files and contain the same directory, which make it easier to support and understand. So for this case, it is very easy to implement because we can have an entry in one entry, meaning if I can use directory D1, D2, D3, D4, D5, D6, D7, and D8, if I am using D1, D2 cannot access file 1, D3 cannot access file 2, and D4 cannot access these files that we have. So each and every directory has its own files. And if you look at the objective of an operating system is to create shareable files. But this is not clear because you are not creating what you call the shareable files. Because if the directory 1 cannot access file 2, and directory 2 cannot access file 3, and directory 3 cannot access file 4, there is no sharing. And for this case, the advantage in this, it is easy to implement. And that's why we are saying, since it is a single directory, so it is implementation, it's very easy. And which uses small files. And when it is using small files, it becomes easier for you to access these files. Because if I want a certain file, I know that I am supposed to go to directory D1. But sometimes if this file needs some addition, we cannot allow addition of these files. So we have to create another directory here that can allow the addition of this file somewhere. So that is why we have some issues with this first level directory. And that's why we are saying if the files are smaller in size, searching will become faster. But what if now you have many files? It becomes very hard. That's why we are saying if I can add some information here in this file, so I have to create another directory that will be able to hold some information that has already been added, which becomes an issue in the allocation of these files. Then we are saying the operation like file creation, search, deletion, updating are very easy in such a directory structure. Why are they easy? Now you have to ask yourself, why are they easy? They are easy because now each and every directory has its own file. So when I delete this file, I'm not affecting this. When I'm deleting this, I'm not affecting this. Yes, we are saying that files are used, we can share files, but now if we cannot allow shareable of files, that means we have what you call duplication. And duplication will now reduce the memory utilization because now we use a lot of memory. But the advantage behind this is that it is easy to delete. It is easy to change the information. But what about the disadvantage? Searching will become time-taking if the directory is large. I think that one we have already tackled because now we are saying we need to take time when we have many files because now you must use different methods. And these methods that we can use in order for you to access these files, one of them, you can use direct access method. You can use direct access method. We can use index access method, and we can still use sequential.
Yeah.
But I think these ones are not new to you because if you look at direct, you go directly to that file, specific file. Index, there is a way that you have to follow a certain line of execution. Sequence, you're using a key field to access this. This one, you're using an index to access that, of which you'll be able to see that in file allocation methods that we need to discuss. So that is why, because of these issues, one issue, because of large files or large directory, then the next one, this cannot group the same type of the files together. So that is the case. That's why I was saying, if I have a file F1 that needs some addition, I have to create another directory somewhere. So that's why we have what we call repetitions. And that's why we cannot say this is the best method to use. It was a traditional method that was mostly used in DOS operating system. Let's try now to change some issues here or try to improve the execution. And for you to try to improve some execution is allowing many users to use many directories. And that's why we go to the two-level directory. And this two-level directory, we often, we say, as we have seen, a single-level directory often leads to confusion of files, names among the different users. Because now, if you are a user one, how will you know that these are your own directory? So user one has to create this directory. User two has to create this directory. But here we are mixed up with users. We don't have users here. That's why we introduce users in this level directory. And when you're introducing in two-level directory, we always use a master level directory. And this master file directory will always assist to create users with their own directory. So if you can look at this, we are having user one, user two, user three, and user four, where user one can create his own directory. User two can create his own directory. User three can create his own directory. User four can create his own directory. So meaning that user one and user two, user one can create a D3 still.
Yeah.
So you can look at where user one can create a directory called D3, whereas the user two has already created a directory called D3. So meaning, still we have not resolved the issue of what you call redundancy. So because this is a master file directory, where each user has its own directory, at least we have allowed more users to create their own directory. So in this case, we can have many files. Just take an example. Nowadays, we are using your own computer. And the moment you are using your own computer, you can create your own directory. So that is user one creating his own directory. Me, I'm using my own computer. I can create my own directories. So in this case, we allow multiplicity or expandability of files that are created within it. That's why we are saying the solution to this problem is to create a separate directory for each user, of which we have already created this. We have already created this. In the two-level directory structure, each user has their own user file directory. So we are not interfering. But what are the disadvantages behind this? The disadvantage behind this is that the files of user one and the directories of user one cannot be shared by user two. So user one has his or her own directory. But suppose I want to use a directory that the user two is using. I cannot share. I cannot share. So the keyword is shareable. It is not shareable. We are not
It's
sharing
more,
files.
it's
Each
more common
user
to it's
has
more
its
common to
own
single
files.
level.
Is there any question?
Yeah, it's like it's more close to the single level directory. This one also.
Yes, it
Because
is
the rest have
almost, it is close to single level directory. But if you look at a single level directory, we are having one entry where we are having many directories that are created in one entry.
Yeah.
But now, if you look at here, we are allowing users. And when I'm talking about users, I'm talking about user as a Mureithi and you as a user. See?
Yeah.
So those are two users. But the issue is you cannot access my files.
Yeah.
And I cannot access your files. The same case to this, where we are having directories here. So we cannot allow another user. We are only allowing one user at a time. So your user is allowed, but here we can have many users who are using different files. Like now, if you use a computer in a network environment, there are many users, but they can use their own functions. It is not a must. I do what you are doing.
Yeah.
Are you getting that?
Yeah.
Are you getting that?
Yeah.
Yeah, hope you are getting that.
Yeah.
Nzioka. Nzioka, are we together? Nzioka amepotea. So in this case, that's why we are saying there are some advantages in that.
Yeah.
We can give full path like username, directory name. Why are we saying that? If I look at most of the files, and I will use a certain directory here that I had already created, and I copy this. If I copy this, and maybe I use it somewhere here, so we are saying we are having a root directory. So this becomes a root directory. This becomes another account. This is an account, user's account. This is another directory. This is another directory. And that's why if you go to C and then I type users for this, inside users I will see Nicholas. Inside C, I will see Nicholas. Can you see this?
Yeah.
Then I can now look at Nicholas. I have what? Desktop inside. Because now the files that are here are in a desktop, on a desktop, sorry. So in this case, we are saying this is a root directory. This is a root directory where this is now the user's account. This is the directory called users, and this is the subdirectory. The subdirectory. So in this case, what we are saying is that we can give full path like user's name, directory name, meaning we now give the full path. So the whole of this is the one that we call a path. And that's why we have two paths. One, we have absolute path, and the next one we have the relative path. We have absolute path and we have the relative path. Absolute path, it is a path from the root directory up to that point, from C to desktop. Relative path, it is the immediate directory, this. If I try to go to the desktop, and maybe I go to this desktop, and I try to open this file. Let me try to open that file. Let me use a directory that I have already created, maybe new. Then I try to right-click this file. So automatically, you find that now you have already added a file in it. And the file that you have added is we have from the desktop, we have added newer folder. So when you talk about relative path, we are talking about the immediate directory. This immediate directory. And the immediate directory is a directory that is close to the directory that you are accessing. There is one of the directories that we understand that directories are also files. So this one can also be treated as a file. So in this case, what we are saying, different users can have some directory as well as file names. So when you're having user 1, user 2, user 3, user 4, user 1 can have his or her directory. So the moment I'm using my computer right now and I give you, you can create your own directory and your own files. So that becomes a two-level directory. It is allowing you to create more users or to allow more users, but these users can create their own directory. Then searching or found becomes more easier due to the path name and user grouping. And I think that one is very clear because if you want to access some files, automatically the first question that I can ask you, where have you saved your document? So I have saved my document in my desktop. So automatically you go directly to the desktop. And when you go directly to the desktop, you can be able to see those files. So that's why we are saying it is easier to access files. But when you talk about the one level directory, it becomes hard for you to access because now it is maybe we are having a desktop where we have created many directories in that, which is very hard for us to access them. It is not like this method that we have, but we have some disadvantages. One, the user is not around to share files. I think that one I have explained, where I have said you cannot share files. Each user has his own files. And if we are having directory 3, user cannot share directory. User 1 cannot access directory 3. User 3 cannot access directory 3. User 4 cannot access directory 3, which becomes an issue.
But you say the user 1 can have the directory.
Yes, user 1 can still create his directory called D. Yes. So user 2 has directory D3. See?
Yeah.
Then user 3 doesn't have directory D3. So in this case, user 3 is allowed to create a directory D3.
That's why
Are we getting that? Let me use Paint to explain that just a bit. I can maybe have, maybe I have a user 1 here. Let's represent those with users. Then I have another user here. See? So if these are users and already we have created a directory D1 and here we have created a directory D2. So this user can still create a directory D2. Are you getting that?
Yeah.
But now you have your own files. You have your own files. So meaning, if this is the user 1, user 1, and this is the user 2, so this user 1 has directory D2, and this user 2 has directory D2. So meaning there is what you call repetition.
Repetition, yeah.
Because we don't allow what you call shareable of those files, which becomes an issue in that. That's why we are saying it still is not very scalable. Why is it not scalable? If you can answer that. What is the meaning of the word scalable?
Scalable as in cannot be scaled to something.
You cannot expand,
You cannot expand, yeah, you cannot expand.
Yeah, you cannot allow modification. You cannot allow addition of other files. And for this case, that's why we are still it is not very scalable. Two files of the same type cannot be grouped together in the same user. So that means where we are saying, if you look at here, I cannot come here and I create another D1 here. So if now this file, suppose this file has already been, this directory has already been created and has already been given a file here, and you want to add something here, you cannot create another file here. So you have now to introduce another directory, which is not allowed. So unless you call it D1 of A, maybe with a different name. It is the same case when you go to a desktop. Can you create the same folder? Maybe I have created, maybe I go to my desktop maybe I go to my desktop, I create a folder, maybe new folder, I call it operating system. Is it possible to create another directory or another folder on my desktop called operating system? Is it possible?
Apart from this. Yeah,
No,
I
I'm saying I'm using a
in the
location
same one.
desktop.
In the same one.
Yeah, in the same location.
No.
No, you cannot. That is why we are saying it becomes hard for that. So that's why we are saying it is still not scalable because we cannot try to modify that directory that we are having. But the only way that we can do this, it's resolving the issues through the use of a three-level directory. And a three-level directory can allow you to share files. That's why we are saying in a three-level directory, once we have seen a two-level directory as a tree of height 2, the natural generalization, and when you talk about generalization, is moving from bottom to top to extend the directory structure to tree of arbitrary height. So meaning, what we have created here, we can allow other subdirectory. Meaning what? If I use paint, maybe to define that, I'm saying I have a directory here, I have users here, or we can create a directory here. Maybe we have directory A and we have directory B, and still I can create another directory. So these are the root directory, these are the directories, and these are the subdirectories. Those are the subdirectories. So when you come to the three-level directory, all these are treated as either files or directories. That's why if when I was explaining this on my desktop, I was saying this directory that I have created here, it is the same as saying it is still a file. It is still a file. You can call this a file or you can call it a directory because this one allows you to share many files in it. And if you look at the diagram that we have for a three-level directory here, we are saying we have a root directory here, but this root directory is able to create other directory. So we are assuming we have A, B, C. Then here we can have D, E, maybe A, B, C, D. So can you see this? Where we have a root directory, but this root directory has the directories. Because root directory is the one that I was explaining here as C, as C. So most of the files that you find here are also treated as file. So this root directory is treated as a file. So in this case, we are saying we can have a root directory. Maybe we have a root directory. If you create a computer, maybe I can use that. If you go to my computer and maybe you go to the PC. If you go to PC, you find that I have created C, there is D, E, and maybe we can create another one. So these are now the ones that I'm saying, these are the root directory, these ones. So being the root directories, what we can look at, we can create other directory inside. And that's why you find that now, when you go to this PC and you try to click inside C, there are some directory. When I go to C, I can create users, there are some directory. When I go to Nicholas, there are some directory. And inside that, there are some files. So in this case, it allows scalability. It allows scalability. It allows you, one key point is scalability. The other one, it allows you to own what you call subdirectories. You can own those subdirectories and organize them accordingly, the way you want to organize them. So you can see here, I have created a directory here, another directory, but this directory is creating another subdirectory. So from top to bottom, that is what you call a hierarchy. From bottom to top, that is what you call generalization. We are generalizing. So in this case, we can say we have created a directory and we have a file. These circles are files. These circles are files. So you have a file. So we can assume here, maybe we are creating a directory, and we have already created this directory the way they have been created. Then we create another directory here. So here we are calling A, maybe we are calling C. A, B, C, and D. Then we create another directory. So maybe D, E. Then we have file. Then we can create another directory inside it. So that means that now we have what you call scalability of files. Up to the time where we understand, we still have some issues here because we are not sharing. If this is a file, and if you can look at this, here we have A. If this is a file that we have, is it a must that I create another file here? That is redundancy because here we hand A. There is no need. Can we share? So three-level directory doesn't allow us to share these files, but it allows us to create more subdirectories. And it allows us to create more directories in that because we have the first level, the second level, the third level, and the fourth level. So in this case, that's why we are saying very generalized since full path name can be given. So we are giving the full path name. And remember, we have said this is the full path name, which we call it the absolute. So this full path name is the one that we are calling absolute pathing. The immediate directory, where sometimes if we are defining that, if you are defining that, we always say it is that new folder. So if you define something like this, we are calling it a relative directory, a relative pathing. We are calling it a relative pathing. So in this case, that's why we are saying it is very scalable. Can you now get the difference between the three-level directory and the two-level directory? Can you get the difference? Have you gotten the difference on that? Nzioka, Hamza, can you hear me? Ruto, Festus.
Yes.
Okay, now if you look at a two-level directory, you have said it is not scalable, sorry. And for this one, we are saying it is scalable. So it means we can try to expand files the way we want. We can try to expand files the way we want. And that's why we are saying the probability of the name correlation is less. If you look at this, we are having some correlations. Because suppose the user 1 create a directory called D1 and user 2 create a directory called D1 again. There is correlation. But for this one, we are trying to avoid correlation. Searching becomes very easy. Why is it easy? Somebody can explain that. Why is searching easy? Members? Michelle, can you answer that? Why is searching becomes easier? I think if you look at these notes, I have already explained that. We can use both absolute path as well as relative what? As well as relative? Are we together? Members, are you asleep? Are we together?
Yes, we are together.
Yeah, so we are saying it is easier to access those files because we can use absolute path as well as relative what? Path. That is now very clear in that. And something that we can now differentiate from others. One, we have differentiated and said it is scalable and it is easier to access files. Even if we have millions of files, we can still access. What if now we are using a one level and we are using millions of files? Is it easier to access them? Is it easier to access them? What have you said about this? When you're using a one level directory, we are saying it uses smaller. Can you see that? So we are saying when you're using smaller files that has smaller size, it is easier to access. But here, even if we are using a very large file, we can do what? we can access. But the issue is shareable. We cannot allow shareable files. Clearly, we have not created the shareable files. So for this, we have a disadvantage. And I think it's very clear that every file does not fit into the hierarchical model. Now, if you look at this, we are having files here, and we are having files here. We are having files here. If you talk about levels, we have level 1, level 0, sorry, level 1, level 2, level 3. So in level 1, we have 4 files. In level 2, we have 3 files. So we cannot fit all the files together. It is not like when you're using a 1-level directory, which are within 1 level. So if you can talk about advantage of a 3-level directory, is that this one allows all files in 1 level. The same case to this. It allows all the files in 1 level. But now the issue is scalable, because if you are using them in 1 level, we don't have scalability. And scalability is one of the important things that we need to consider here, because now we cannot say that we have created 1 file and that is the end of those files. We can try to create and modify. That's why your computer, the computer that you use, it allows you to create more files. You can create millions of directories, irrespective of maybe other directory that you have created. Looking at one consideration is the hardware. And the hardware, we are looking at the size of the memory. So are we able to create that? That's why we still say this is not efficient. And we can say we cannot share files. And I think that one I have insisted on it. We are not sharing files. We cannot share. Here we have levels, but not shareable files. Then it is inefficient. And I have explained and said, because accessing a file may go under multiple directories. Because accessing a file may go under multiple directories. Now, if you're looking at this, we can have root directory. For you to access this file that is here, how many directories have you passed? Somebody can answer that. From the root directory, how many directories have you passed so that you can access file this?
1, 2.
So you have passed 2, 1, 2, and the root directory. So let's call them 1, 2, 3. Now it is very tedious for you to access that, because you have to move from one level to another level. Automatically, when you go to this level, you don't know how many files are there. So it becomes hard for that. That's why we are saying it is inefficient, because accessing a file may go under multiple directory. But now, try to solve all these issues that we have. And when you try to solve these issues that we have, it is through what you call a cyclic graph directory. I would like maybe to combine that with what you call general graph, because they work together with general graph. And when you are talking about a cyclic graph directory, so it means if you have already created a directory, and maybe we have created a directory A. Let me try to use Paint so that I can explain this. If you try to use this directory, and maybe we can have 2 directories. Let's use 2 or 3. Maybe we can have A and we can have B directory. So this directory allows you to create another directory. Maybe you can have D, you can have E. This one allows you to create another directory. F, K. Please, can you switch off your mic? Please, can you switch off your mic? You can use your mic when maybe answering a question, because there is a background echo.
Okay.
Okay, so what we are saying is, we have a directory D and a directory E. Here, let's assume that we have a file. Then here, maybe we call it file 1. Then here, we can have another directory. And this one, we call it K, we call it M, then here we call it N. So for this one, maybe we can have a file here. We call it file 2. Then here we have another one that we are calling J and N. Remember here we have now a directory called N in subdirectory E, but we have N in subdirectory K. Suppose now we introduce file here, and we introduce another file here, and we introduce another file here. Maybe we have exhausted the directory. So if you look at this, what we can say, because now we have a directory called N in subdirectory E, and we have another directory N in subdirectory K, this one can share this file, can share that file. So in this acyclic level directory, we are allowing what you call shareable files. And that's why, if you look at these notes that I have here, we are saying a cyclic graph is a graph which knows cycle and allows to share. The keyword is what? Share. The keyword is share. Subdirectories and files. So in this case, I can still share. Maybe I can have another directory. Maybe we can say this directory is sharing with this. Suppose we don't have this file. Suppose we don't have that. So this subdirectory can share with this directory. So we are having what you call shareable files and shareable directories. Have you now met one objective? If you remember in introduction, we said one objective of an operating system is to allow shareable files. Have you met that objective? Somebody can answer that. So I can maybe ask somebody, Ochieng, you can answer that. Are we allowing shareable files? Ochieng, say yes or no. Hey, Ochieng, you are asleep. Ruto.
Yes.
Yes, there is what you call shareable files. And that's why we are saying a cyclic graph is a graph with no cycle. What is the meaning of this? It doesn't repeat itself. Seriously? Doesn't repeat itself. It's like now, if you create a file here, we don't, like now, if you look at this, I have not repeated a file, maybe a file 3. I have not repeated a file 3 in this subdirectory. I have joined them together. So I have shared. So this is what you call shareable. So we are sharing that, shareable files. So in this case, what we can say is that the same file or subdirectory may be in the 2 different directory. Can you see that? And I think I have explained this. It can be the 2 in different directory. It is a natural generalization of the 3 structured directory. So we are now borrowing some knowledge from this. Because we cannot borrow from this, why are we not borrowing from the 2-level directory? Why are we not borrowing? Because in this, we cannot allow shareable. But for this, we can allow shareable because there is more directory that are created. And if you can create more directory, we can still allow shareable files. That's why we are saying we are borrowing some characteristics from the 3-level directory. So we are saying it is used in the situation like when 2 programmers are working on a joint project and they need to access the file. That's why I remember saying you cannot create operating system alone. We must have different programmers. One is doing process management, the other one is doing memory management, the other one is doing file management. So all these, they have to combine together. And when they combine together, now you can say they are now sharing some executions. So in this case, what we are saying, if you look at this diagram, and I think I have explained using a paint, it is now representing, don't cram these, my friends. Here we are not cramming. Are we okay? Michelle, have you waken up?
Yes.
Okay. So we are not cramming here. We can use any letter. That's why I've used A, B, C, D, or any other. Remember, we can use these types. Remember, we said we have different types. One, we have RTF. We have RTF. And when you're using RTF as an extension, we are saying we are converting text in a manner that the user will be able to use it in data mining. So for those people who are doing data mining, they always use .rtf, which is not in a given format. We can still use .doc. We can use doc. Here I can come here and I say doc. Instead of A, here I can use PDF, etc. But for a general understanding, just use ABCD so that you can be able to clearly explain that. It's not a must to use those. So that's why if you look at this diagram, we have a directory. Maybe this is A and this is B, but it has a directory. Root directory has its own directory. Maybe this is C and D. So directory C has a directory A, B, C, D, K, L, J, etc. But it has its own file. So can you see this file, which is in this directory, is sharing with this, the way I have explained here? Are we together?
Yes.
Yes. So there is allowing of shareable files. And that's why we can say we can share files. That is the main advantage. If you omit this, I will give you a 0, even if you have gotten it right. Then searching is easy due to different paths. Different paths. Different paths. Which are those paths? One path that you have, I can use the same. We are having the first path is this. Serial. You go up to this point, you access those files. The next path is this path, you access this directory. The next path is to move to this, then you access. So you have different paths. So it becomes easier for you to access. Now, the question that you're supposed to ask yourself is, when you are using this directory, how will I allocate files inside those directories? How will I allocate those? So that's why there is a topic that we need to discuss here, which is called file allocation methods. File allocation. And this is the simplest subtopic, because now all these directories that we have here, we have already created them. But now we need to ask ourselves, how can you create a directory? Remember I said that when you're creating a directory, we must use a command prompt. So I just type CMD, and when I go to the CMD, this is the root directory, user's account, and this is the subdirectory. So for you to create a directory, maybe I can explain using this. We use what you call mkdir. That is creating a directory. Creating a directory. When I want to rename, I use ren. I use ren, rename. That is, you rename directory, rename. When I delete a file, I use del. Because we are using Windows, that is delete. But if I'm using Linux operating system, I use the word kill. I'm killing a process. So you kill a process, e.g., you can say kill the process ID. Maybe you can call it X or Masi. So you are killing that. We can still do what you call copy. We use copy. So we are copying a file. We are copying a file. Remember, we are using that structure. Now, I want first of all to create a directory. I use Paint to come up with the directory. Maybe I create a directory called A, and within directory called A, I create a file. Maybe I'm using a one-level file. I call it .doc. When I'm using a directory, I use mkdir. But now I want to create a file. I use what you call copycon. I use copycon command. I use copycon command. So meaning I want to create a directory, but I want to create this directory in my desktop. So when I want to create on my desktop, I have to change the path. I have to change the path. For you to change the path, you say, before we go to that, dir, that is display. Then to change the path, we go to cd, change directory. Change directory. And I think you can see what I'm typing. Can you see what I'm typing?
Yes.
Yes. So now we move to this. So I want to change it to desktop. I type cd space desktop. Then I have used tab instead of typing desktop because I can type with small letter, whereas it is supposed to be in capital D. Then I press enter. Now I'm in directory desktop. So I say mkdir, and I call it, I can call it e-learning class, e-learning class. Then I press enter. Then I press enter. So when I go to my desktop, I'm supposed to see e-learning. Can you see e-learning? This is the e-learning that I have created. But if you right click this, it is having a 0 byte. It is having a 0 byte. Why is it having a 0 byte? Because you don't have a file inside it. So what you have said, I have created a directory called e-learning. Hey, let me use E to represent e-learning. Studio. Then I want to create a file inside e-learning. And this should be a text file or a document file. So in this case, I now say copy con. What are you copying? Con. You copy con e-learning. Then I create that file called operating.txt. So meaning we are creating a text file. The syntax is incorrect. So copy con e-learning. Then I call it, maybe I can say os.txt. Okay, just a minute. Then I look at maybe what are the issues on this. Con os.txt. OS, okay. Copycon os.txt. So the issue is I wanted to create inside this document, this e-learning that I have here. Maybe we can try to change this. Let's try to change this. Maybe we can end that. We go to CMD and we can say maybe CD desktop. Then I call it CD e-learning. Remember, I have created a file called e-learning. So I'm inside e-learning. So I say copy con operating dot doc. Let me call it dot doc or dot txt. Then I press enter. When I press enter, it allows me to write something. Maybe I can say I love operating system. Operating system. I hate nothing. So in this case, we have already created a file, but inside this file, we have now created. We have created a directory, but inside a file, inside a directory, we have created a file, and inside a file, we have written something. So let me open the directory. So I open that directory. I go to operating system, operating. Can you see that file? Then I can open that. So inside it, I have operating system, and I hate nothing. Are we together up to that point? Members, are we together?
Yes.
Yes, hope now you can create a file. You can create a directory. Inside it, you can create a file. Are we together? So in this case, I want maybe to move it. I want to move this directory. So for this case, there is an issue when you use escape that I want to terminate completely. Then I go to CMD again. Then within this, I change the directory. I call it desktop. Desktop. Then I can say CD, I go to e-learning. I change that if I want to change. Or I can go back. When I go back from e-learning to desktop now, I type CD with the 2 dots. Then I press enter. Hope we are together with that. So in that, I had moved from desktop to e-learning. Then I have moved back, one step backward. So in this case, we can now allow the user maybe to move e-learning. You can move. What's the difference of moving and copying? Move, you move all the whole structure. Copy, you retain the original structure. So you retain. So it's like you are copying something, you move, you take it somewhere else, but you retain that original structure. So in this case, I want to move completely. I move. Where am I moving? I'm moving this to document. Maybe I can move e-learning, e-learning. I move e-learning, but I move, so there is a space to document. Or maybe, let me see the document. Just a minute, document. Because we must know how the document is typed. In this, capital D, in documents. I don't know why it's not working when I press tab. So documents. Documents. And then we move with that arrow. Then you press enter. The system cannot find the path specified. So that is the issue. So we move. Let me maybe, for the sake of time, let me first of all create another directory here. Maybe we move to operating system. You can move it to operating system. So move e-learning to operating system, to operating system. Then we move that. So can you see one directory moved? One directory moved. Now, in this case, if I go to this desktop, I will not see e-learning on my desktop. But when I try to open operating system, I'm supposed to see e-learning inside my this. Can you see that? Is it clear for that? So yeah. It is possible for you to move something inside it. Now, I want to delete the file that I created inside the directory. I want to delete it completely. So what I can do is to now change the directory, or you can use del, then operating system, then inside in operating system, because it is inside, you have what? E-learning. Because we are moving from one directory to another, when you're moving from one directory to another, we use a backslash. We use a backslash. Then after that, we have a space. We have a space. What are we deleting? We are deleting the operating. Inside, we had what? If you can go back, inside it, we had e-learning, then we had operating. So we move, then we have operating. Just a minute. So we have Dell operating system. We are moving to another level. So we use the /. Maybe we can first of all use that. We press enter, we say yes. Do you want to delete that? Maybe we can say yes. We type Y. And then when you move back to your directory, inside this, we are not supposed to see the file. So if you use Dell, and then we type operating system, because now our file was inside another directory. So we have created a directory inside another directory. And inside that directory, we are now supposed to delete a file inside e-learning. That's why we have said Dell operating system, because we are moving to another directory, we use the /, we say e-learning. Then that e-learning we press enter. That's why we had a question here. Are you sure? Say yes, /N. Because I'm sure I want to delete it, I use Y. Then I press enter. Automatically, it moves to the next level. And when it moves to the next level, so you cannot see this directory inside it. We cannot see that directory inside it. Up to that point, do we have any question? So maybe we can ask questions. Can we ask questions if you have it? Testers?
So the best kind of directory to use is the third one, right?
Hamza, can't hear you.
Yes, I'm saying the best kind of directory to use is the third one.
Have a clear question, please. I can't hear. There is an issue.
I have told you.
Yes.
The best kind of directory to use is the third one, right?
Yes, it is the third one, which is a cyclic level directory.
Yeah.
And the cyclic level directory, we have said, it allows the user to share. Yeah. Can you see the directory that I was creating here using my command prompt? I was sharing. Because I created operating system, I shared that directory with another directory. So inside that directory I created. So the best one to use is a cyclic level directory.
Level, yeah.
Yes, it's not the 3, because the third one is the 3, of which now we are borrowing some characteristics from the 3 level directory, so that we can come up with what you call a cyclic graph level directory.
Yeah.
Yes. Root of Estes. Is root or in? Is anybody with an issue? Because I can see Ruto is saying that I can't be able to view what you are sharing. And I think it is on your side, because I had shared everybody. So on my side, I'm okay. I can see you. Nzioka? Nzioka, do you have any question? Ochieng? Ochieng Alan?
Yes, Mwalimu.
Yes, do you have any question?
No.
Okay, so it is clear. So please, those are a few commands that we have worked with. And you must know that now these are examinable. It is examinable in NEC. So you can be given a structure of a directory. And if you go to your past papers, because for any class that you'll be having, please be coming with your past papers. For any directory that, for any question that you find in your question papers, it has to ask you maybe how to create a directory and how to rename maybe. And I want us to rename the directory that we had already created. And the directory that I want us to rename is e-learning. Remember, e-learning is inside the operating system. So the first thing is to change this directory. So we can still use REN, operating system, which is now on my desktop. Then I use the backward slash. Then I use e-learning. Remember that now I want to rename e-learning, but I want to rename e-learning as happiness. I want to call it happiness. Are we together with that statement? That is the path, that is the absolute path. Then I press enter. So if I try to open this directory manually, can you see any e-learning somewhere? Can you see e-learning? Members, can you see e-learning? Already we have created a directory and now we have renamed it to happiness instead of now e-learning. Instead of e-learning. That is when you want to rename that directory. So I would like you to go to your command prompt during your free time and just type the word help. Type the word help. And those are the commands that you'll find on your help side or a window. And now you can work with those commands. There are many commands that are here. You can try to work with them. And maybe if there is a question next time, maybe you can ask before we continue. Members, are we in the same point?
Yes.
Yes. So please try that. If there is any question, you can ask. Go to your question papers, the next question papers, and mostly, if you go to question paper for 2016, you can find that there is one question, and that is certificate paper. So please go to those past papers, and you can maybe get some questions from there. Then if there is a question, you can ask. Now, is there any question up to that point so that we can continue? Is there any question? If there is a question, you can raise up your hand. Is there any question?
Yes.
Yes? Michelle,
Okay.
can you ask?
Okay, I was asking about that single directory.
Single level directory, yes?
I didn't get the point of accessing a file may go.
Accessing a?
File may go through what?
Oh, okay. If I can repeat that, I will go directly to that using my notes. If you look at the one level directory or the single level directory, when you are now restoring files, it means we have only one entry. And the one entry I was trying to explain in that it's like when you're using your computer allows only one user to use it, but we cannot allow another user to use it. And that's why I'm saying this was a traditional method where this user one, so assume that you are using your own computer. This user one, using your own computer, you have created directories on a desktop maybe. But now you cannot allow another user to utilize. If I come to your computer, maybe I cannot access them or I cannot create another directory. So that's why we are saying in this level directory, being a traditional level directory, it was only allowing one user where it was not allowing what you call scalability. We could not expand the directories that we had. If we have a maximum of 10, that is the maximum of 10 for that user. If another user comes, we cannot create another one. So it's like now I'm creating a directory D1. Then when I want to create a D1 on my document, I cannot create because it allows me only once to create only once. And that's why if you look at the disadvantage here, we were saying there may chance of name collision because two files cannot have the same name. Because now we cannot allow the user to create in a different allocation or different location, we have collision. That's why we said we only use one user. We don't use two users. Am I clear, Michelle?
Yes.
Yes. Is there any question? Zioka umenyamaza bana. Is there any question? Madi? I can see you are typing. You still have an issue with the Is there any question? Is there any question? Can we continue? Ochieng?
Yeah. Yes.
Okay, Michelle, can you ask?
I've said you may proceed.
Oh, okay. Let's proceed. I want to explain the next part. The next part is now the file allocation methods. Remember, we have now created files, but how will you allocate them inside those directories? So that is now why we need to look at various types of file allocation method. And one type of file allocation method, if I can use PowerPoint to maybe define that, we have what you call contiguous. And I remember there is a time I defined what is contiguous. And I said contiguous is a systematic way of allocating files, one after another. Then the next one, we have what you call indexed allocation. And the next one, we have what you call chained allocation. Chained allocation. So in a contiguous, we have to allocate files one after the other. If I allocate A at this point, the next time I allocate A plus 1. So meaning, if we are having some allocation, let me use a paint. If we are having an allocation here, we have allocated A. The next one, we have to allocate it. We allocate B here. The next one, we allocate C here. The next one, we allocate D here. But now we are using storage. So we are using storage. And this storage starts from 0. Maybe we have 1, we have 2, we have 3, we have 4, etc. So I need to have files. Maybe I have file A that this file, it has blocks. And the block that we have block 1, we have block 2, we have block 3, we have block 4. Or maybe we have block 6. So this is 4, this is 5, and maybe we can have 6. So the start bit or the start point is at 1. So we allocate 1 here. Then we allocate 2 here. We allocate 3 here. But the next one that we are supposed to allocate is 6. Remember, we have omitted 4 and 5. So the problem with this allocation is that if there is another file that you want to allocate in A, and maybe this one we have to allocate file, maybe another one, maybe like file 4, we cannot allocate it here. Or maybe we have allocate 6, we cannot allocate it here because they must be contiguous. These ones we have already omitted. So you have now to go to another allocation here, meaning there is what you call inefficiency in file allocation. And this inefficiency in file allocation is the one that results to some issues, because now we cannot have a clear access of these files because now we have omitted a separate location. If I look at these notes that I have here, we have said we have contiguous, we have linked allocation. Linked allocation, another name for linked allocation is the one that we are calling it chained allocation. It's the one that we are calling chained allocation. And we have said the main idea behind this method is to provide efficiency. If the method cannot provide efficiency and the disk space, as we have seen here we are wasting a space. Now, that is not a good method to use. Fast access to the file blocks. If you cannot provide fast access to file blocks, that is an issue. And I want us to look at the first one, contiguous allocation. And we are saying, in this scheme, each file occupies a contiguous set of blocks on a disk, contiguous allocation. And this is why I'm saying maybe following each other. Following each other. We should not omit a disk space in that allocation. A file requires n blocks. N is the number of blocks that we have. Maybe you can have 20 blocks that we need to allocate, but we need to allocate them contiguously. If the start bit is here, now we cannot jump to this. We have to allocate them contiguously, following each other. And that's why we are saying this block is like we are having B plus 1, B plus 2, B plus n minus 1. And that n minus 1 is the last block minus the minus 1. And if you look at this block that we are having here, we have file count, 0 start. How many length? These are the length that we are having here is the number of blocks that we are having. And the number of blocks that we are having are 2 blocks. That's why if you are starting from 0, we have 0 and this 1. We allocate these 2 lengths. We allocate them. Now the issue is, do you know the size of these blocks? That's an issue. And if you don't know the size of these blocks, it becomes an issue, because now when you are allocating them, you might allocate a file which will not be fully accommodated where it is supposed to be. So that's one issue that we have. Then, if you look at the second count, we have 14. We are starting from 14. But how many blocks do we have? 3 blocks. So we move to 14. And we have 1, 2, 3. We allocate them. And we are calling TR according to the diagram. Then the next one is for male. We are starting from 19. Then we start from 19. How many blocks? 6. 1, 2, 3, 4, 5, 6. Then the next one we have list. We are starting from 28. How many blocks? 4. 1, 2, 3, 4. Then we have 6, which has 2. Now, all these are memory unutilization. And for this memory unutilization are the ones that result to submission. Because if file 1 requires, let's say maybe we have what? Maybe we have list. We want to add list, maybe to have 6 blocks. Where will you allocate them? Already, we have exhausted the memories for allocation. That's why we are looking at now the advantage. Both the sequence and direct access are supported. You remember when I was talking about sequencing here, there is a point where we said we use sequence method. If I think maybe I used some, okay, direct index and sequential method. Where we are saying we can use sequential method, one after the other. And if you look at now, you have piles of files, and these piles of files, we have to access one after the other. If I want a file for 1980, remember there at the top you have 2020. So you have to move from one after the other. So you take months to access those files up to 1980, because those are many years. Those are about what? 40 years, if I'm not wrong. So in this case, we are saying both the sequential and direct access are supported by this. For direct access, the address of K, that is K means that is the last file that we have. Start at block B. So we are looking at this is the K. K start at 0. K start at 0. So you have to move this. If I want to access file 31 or allocation 31, I have to move from this point. I move until that one. So I use a lot of energy and time. So that's why we are saying this method, because we are using contiguous allocation, it might be fast to access the files. So this is extremely fast since the number of 6 are minimal because of contiguous allocation of file blocks. So you find that because now we are allocating them contiguously, we can access them faster, but now become an issue when you're adding them. So an issue is adding files because you cannot add file for count if now we are assuming that the next file was starting from 2. If we had another K, maybe here starting at 2, we allocate here. Now, where will you allocate count? We have an issue. That's why we must understand that we can now go to linked list. And if you look at linked list, we are saying we can now have file 1 linked to another file. Maybe we can have this file, if this is the first one, linked to this. So we are using what you call pointers. We are using pointers. And I think I can use this diagram that I have here. Maybe the diagram is very clear. I think it's very clear, if I'm not wrong. Is the diagram clear? Members, is the diagram clear? Okay, it's clear. So for this case, we are assuming that we have file zip, and the start point is at 9. So for this case, if you are starting from 9, we have to look at this 9. So we are starting from 9. You move. We have end is at 25. End is at 25. So for this case, you must know the file links that are supposed to be there. And if you look at this diagram that we are having here, we are moving from 1 to 16. So most of the links that we have 16, we have 1, we have 2, then we have 25, where we are supposed to allocate here. That is -1, which is at 25. So we move from this to this, we move to this one, we move to this until the end. So it means if you are having some file, maybe some file allocation, and we have some issues, and this pointer is removed. If you remove this pointer, it means we cannot access these files. That is one disadvantage that we have. And that's why we can see one disadvantage that we have, it doesn't, pointers requiring the linked allocation require some extra overhead. And the overhead is, if you are trying to access the files and you delete this pointer, so automatically you cannot access these files that we are having here. So that's why we have some issues in those allocations. So in this case, we have tried to reduce the problem in the allocations, and we have tried to create an easier way of accessing files. That's why we are saying this is very flexible in terms of file size. The method does not suffer from external fragmentation. And you know what are external fragmentations? It doesn't suffer. Why is it not suffering? Because I will be able to follow the link. So we can use what you call sequential method. And still, I can use the direct method. So in this case, if you look at what we have explained here, we have said, contain a pointer to the start and the end of file block. Each block contains a pointer or the next block occupied by the file. So these are the pointers. If you delete pointers, becomes an issue. If you now want to access the file, you have to access the file from the first point. So I access from here, moving up to the last point. So it still takes time, but at least we have tried to resolve some issues on that. Because of the file blocks are distributed randomly on the disk, a large number of 6 are needed. So when I talk about 6, this is the time that you take to access a certain file in a given file. So a large number of 6. So you have large number. So you take time to access, because if I'm accessing one, I have to move from this point. I move up to that. So why am I moving to that? I can use direct, but it is not around that in use of that. But the best method to use in allocation is what you call indexed allocation. index allocation. At the moment you're using index allocation, it is the same way we use some indexes. And we say these are indexes that are supposed to point. And that's why if you look at this diagram that we are having here, we are starting from 10, but this from 19, but this one is the one that is now holding the index for all others. And if you look at this diagram, most of the pointers are starting from this index. So if you delete this, becomes an issue. But if I delete this, I can still access this. The issue was here we cannot access the next file if you delete a pointer. But here I can access files even if I delete a certain pointer. The only problem is when you delete the index. But when I delete this, it will not affect the others. That is one of the advantage, or the main advantage. So we are trying to overcome the external fragmentation, and that is why we have said we need to use links. But these links that we have, we must use some indexes for that. So it allows me to use different connections. And that's why we are saying they support direct access. So automatically you can move here and move directly to that. It's not a must I pass here, then I pass to this so that I can access this file that is here at the end. So I move to that file directly. So if you can look at what we are saying, is that we have different methods of file access. One is direct, random, and sequence. But most of them that use is random access file. There are others that we call hash methods, but I don't want to explain hash method at this point because it has to use some algorithms to access it during the access of those files that we have. So members, if we are okay with that, that becomes my end of presentation, because those are the main allocation methods that you can have. And we now able to understand them. And if you look at the last one that we have here, just avoid this. This is mostly, it's an implemented mode that is now mostly used within the Linux operating system combined scheme, which uses all the methods that we have already worked with them here. It can use index. It can use this method that we have already talked about here, contiguous. It can also use linked list. So it uses combined method of those three methods that we have already talked at them. So members, we can end at that point, but I want us to meet in chat room so that now we can raise some issues there. And then I'll be using Wiki, so I can post a question there. Maybe we challenge that question. And when we challenge that question, maybe we'll be able to get a clear definition of what we have already covered. So please let us meet in chat room. And the next lesson that we'll look at now the file system. File system, that is next time. File system, there are different file systems that we are supposed to discuss. And then after that, we look at the security, and we call that the end of our topic. And now we can start revisions using next past papers. So that's why we need to be serious in this. Members, now we can try to write a message, or maybe if you can talk, maybe you can say you are okay, we proceed to the chat room. Maddie, I have seen your message. Sir, I join it now. Kindly, will you? Okay, I will send those notes to you. I will send notes to you. And there are some notes that I have already sent to you on those portals, so you can download and read them. I will still add others. These ones are not there. I will add them, please. Is there any question up to that point? Can we move to chat room? Raise up your hands. You can still raise up your hand. Can we move to chat room? Members, move to chat room. Raise up your hand if you can see me. Write a message. Let me start with Alan. Alan, can we continue? Michelle, can we move to chat room? Nzioka, I'm waiting for a response. So you can either type a message or maybe you talk. So I can see Madi has written, sir, where can I get the notes? So please, when you go to your portal, automatically, there is a point where we have notes page. Maybe I can direct you to that point. You can see this. So please follow this link. If you go to your first page, this is the first page that we have. And if you click here, those are the notes that I'm talking about. And still I will add others. I will still add others. Here you can click. I hope I have solved those issues for now. So when you click here, you can see notes. There are some notes here. You can read them. And that's why I've said I will add others. I will add others. Are we okay? Okay, Zioka, I've said you can see those notes. Okay. Okay. Let us now go to the chat room so that we can maybe brainstorm on what we have understood. And thank you for listening to me. Thank you.